Everyone, it is July week 4. We have some new features to show off from the community team. Let's get started. First up, we have Colin.
I have a live demo that we're going to try here. I've given everyone a link to try and join. If you load this link up, I was going to try and prime this with some other stuff first, but it didn't line up properly here. I'm sorry for background noise here. Still loading up. So this is a very simple plugin with a JavaScript component and a server component. There's no authorization or authentication on the server, so we can't tell who people are, so it just generates a random name for each person. And as people join, they can click on that room and type messages. This is a table here that renders exactly what people are doing. And you can create more channels. Channels create more tables as necessary. And as you join and as you leave, it will send other messages, not as plain table input table stuff or any other way of uploading things like a do put, but actually by calling the specific methods to say, here's how we want you to upload data to the server. Then on the server, it has to decide, okay, well, based on what I know about the message that was passed to the server and based on what I know about the user themselves from their exec context, go ahead and, why is this not working? Thanks. Go ahead and modify the table, in this case, using a dynamic table writer. So this is a way to say any data you want to send from the client to be able to do whatever you need to on the server. You can write your own validation code there. The implementation on the JavaScript side is, sorry, I'm getting pop-ups here. Implementation on the JavaScript side is the same as the existing widget API we have, where you can add handlers and you can read exported objects. This message is new. We did not have an event handler on this previously, but you can listen now to say, hey, a message came from the server. What kind of a message was it? And how do we handle that? This one's written using just binary encoding. It could just as easily be JSON. And then the server implementation is likewise just saying, okay, switch case based on which command was sent to the server, and then read whatever the user printed when they say they want to send a message. And there's a simple implementation that uses dynamic table writer to write those specific details into the shared table for chat. So it will not run for very long, unfortunately, because the proxy I have in front of it doesn't handle it very well. But it does at least run, and it will run properly with a real server.
Cool. JJ, you want to share what's up next?
Sure. So let me share my screen. So what I'll be demoing today is a fun little example I put together earlier this week. So we've had some discussion around AI and large language models and just cool integrations with AI in general. Sure, I share the right screen. Okay. And so I decided it was time for me to join in the fray, and hopefully everybody can see my screen. And if not, just let me know. But specifically last week, Christian sent out an article about something called Table GPT, which I read, and it was pretty interesting and kind of, again, made me really want to at least try my hand at some interesting integration with AI. And so what I ended up stumbling upon earlier this week, or late this past weekend, and put together mostly on Monday, was I integrated two things, Deephaven and something that I found called Weaviate. Weaviate is an open source vector search engine that can be used to power things like large language models and semantic search. So I put together a simple example that's here in a Deephaven examples repository if anyone wants to go check it out. But essentially, it uses Deephaven and Weaviate essentially to show a simple example that could serve as the backend for a semantic search engine. For a little bit of background on semantic search, I'm not exactly an expert in this field, but basically, lexical search is the idea of searching a database for an item and only returning items that contain an exact match, whereas semantic search uses AI to vectorize data that would otherwise be indecipherable by computers, for instance, text data. So it uses these big AI models to vectorize these words, phrases, sentences into these n-dimensional spaces And essentially you can find neighbors. So let's say I enter the term, so for instance, this particular example, I uploaded a bunch of data for books, and this is essentially a book recommendation engine based on input search terms. So on the bottom left here, I have a table called book genres. I type in something I'm interested in. Let's say I want an adventure book. Enter, and I commit, and then in a second or two, I get an answer back with a book recommendation. In this case, it recommended The Adventures of Tom Sawyer. And so basically what's happening is that Deephaven takes this input data, sends, when I instantiate this Deephaven instance, it will go to this free tier Weaviate cluster that I created. It will create a class. Everything, I guess, in Weaviate works in classes, and the class is called book, and essentially it uses a built-in vectorization engine from Hugging Face in order to vectorize the data. So it's the free tier. I only have like 100 books in there, so it's not going to get all that exciting results, but I can search for basically anything I want, and it'll just keep giving me different results based on semantic search using AI on the back end. So yeah, it's a simple example, and you can give it more than one search term, but just to demonstrate that these two things work together pretty seamlessly. Took not a whole lot of code to put this together, just package it up with Docker, and I think it's pretty neat. So anybody who's interested in how these two things work together, I just recommend checking out this Deephaven examples repository, and hopefully we'll have a blog about this stuff and maybe some more content next week for people to read about.
Cool. That's it for this week. Thanks, everyone. Bye.